wabarakatuh. Bapak Ibu dosen pengampu, kemudian para mahasiswa sekalian di mata kuliah Studio Desain 3. Senang sekali hari ini kita bisa berjumpa kembali setelah masa UTS atau ujian tengah semester, di mana kita hari ini akan membuka paruh kedua dari semester ini di mata kuliah Desain Studio 3 dalam public lecture atau kuliah umum dengan tema Introduction of Building Systems. So I'd like to introduce first to our speaker. He is Assistant Professor Dr. Arif Wismadi from Laboratory of Architectural Communication and Business. Let me share the screen for the CVs. Apakah layar saya sudah terlihat?
Partly, Bu. Only a half.
Only a half? Okay.
I don't know. And from my side, it's just...
Okay. Yeah, hopefully it's clear right now. So he is Assistant Professor Arif Wismadi, Dr. Arif Wismadi. He is the Director of Growth Hub or in Directorate of Entrepreneurship Development, Universitas Islam Indonesia. And he's a lecturer and researcher in Department of Architecture, of course, in Faculty of Civil Engineering and Planning in UII from 1993 until now, and a member of Ikatan Arsitek Indonesia or IAI. And he is too a co-founder of Indonesia TRIS or Teoria Rationia TRIS with Practitioners Association in Indonesia. And then from the educational background, he gained the architecture bachelor or engineer in Universitas Gadjah Mada and International Institute for Geoinformation Management and Earth Observation in ITC Twente in Netherlands for his M.Sc. And then for doctorate study, he was a doctoral graduate from University of Twente, the Netherlands. And yeah, he gained some projects in project management experiences in researcher in Erasmus GITA and project manager for Erasmus Plus, and then project manager for European Small Project Facility from 2005 up to 2006, and etc. We already know his track record, and right now he wants to share to you guys his perspective on introduction of building system as our course material for week 6. Yeah, for our course week 6. So yeah, before we start this public lecture, let us recite Basmalah all together. Bismillahirrahmanirrahim, so that everything will be manfaat for all of us. And please, Pak Arif Wismadi, the screen is yours.
Okay, thank you, Bu Lia. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Nice to have you all here. Very good afternoons. Shall I deliver in bilingual or?
Yeah, hopefully it's bilingual, or at least the presentation is on bahasa English or okay, and spoken in bahasa. Thank you, Pak Arif.
Okay, so I will try to have most of the time in bilingual, but if the time is not allow us to have double statement or delivering it doubly, so I would like to start right now with starting with it's like can you see the screen now? Trying to have the best view on it. Can you see that?
Yep, it's clear.
Great. So again, thank you so much for attending this lecture. So in this case, actually, during this occasion, I would like to introduce the building system, introduction of building system, because some of you just in the semester 3, I believe, and somehow the content that I would like to refer maybe beyond beyond the third semester, but it's okay because it will bring you up in the higher level than your semester. But of course, which part that you can apply is depend on the case. And I only have three contents. First about the what and how and example. What is not about definition, but the concept that they have to discuss during this lecture. And how actually, what the idea that has been delivered during the discussion, the what, the content, will be answered by a systematic method to make sure that the what, the expected what can be delivered. And then the last, I will give you some example on it. Again, I'm not talking about the definition, just showing first about the first reference that we can use if we'd like to learn about definition. One of the nice book that we have is Integrated Building by Leonard Bachman. So if you would like to know about the definition, you can read about that, the concept behind such ideas. But I will not log, I don't want to discuss or explain all the part of the books, but only some part of the book, especially chapter 3 about integrated building system. The rest about the ideas, the definition could be found in this list. And then I would like to deliver some of the example of the case studies, just showing how actually we can deliver or we can present how our design has been provided with the idea of integrating several aspects of the design. So first, let me discuss about the integrated building system requirement. Actually, we believe that within a certain space within the building, we have to share the space. Some of part of the building will be contained with the structure. The other may be function. The other part may be activities, and then non-structural aspect and other things. But the problem is there is very limited space inside the building, and we have to put everything all together. So in this case, actually, we would like to have kind of a compact space, which is in terms of physical integration, we deal with the shared space. The second one, because everything when we put inside the building, so the building would be look like something. So the image of the building could be affected by the content inside and the something outside on the skin of the building. So in this case, we have to deal with the visual integration. And the last, because our building have to be functioning in a certain way to serve the users, so we have to make sure that there is a performance integration. It is a shared function. So it's mean the function of the building, not only single function, but the element of the building and the space of the building also have shared function. So they should not conflicting in a way that one will affecting the others, and therefore the physical will be reduced, or visual will be reduced, or performance will be reduced, but altogether should be not defeating in each others. I think. Do you think it's okay for Indonesian student? I just continue in English, because speaking in two language is not very convenient actually. Jadi nggak enak juga kalau separuh bahasa Inggris, separuh bahasa Indonesia. Dikira-kira.
Oke, Pak Arif.
Dikira-kira aja, kan teksnya cukup pendek juga. Okay, let me continue in the international language then. So in this case, actually, we have to be aware that our building consists of several considerations. First of all, the environment that we have to deal with, and then the resources that we have, and then there is kind of consideration of management. And in the context of building system, we have a list of appropriate system, appropriate component, including site, structure, building envelope, surfaces, and interior. And we have to integrate because we have to share space, share image, and in this case, the beneficial integration could be a product that consists of, again, a physical integration, which is mutual space, shared space. And then we have visual, which is mutual image or shared image, and performance mutual mandate. So in this case, I would like to discuss a little bit what mandate for each part. So in the component level or the system level that we need to integrate, at least we have to have include or consider the envelope. The building envelope has a specific mandate to spread indoor and outdoor condition. And then to make sure that the building is live, then we have to put the services, including air conditioning system, and then electrical, plumbing, vertical transportation, life safety system, and others. And then, of course, to make sure that the building could be constructed and robust in terms of affected by, let's say, earthquake, we have to make sure that the structural thing has to be there. So in this case, the structural element will provide static equilibrium against gravity and dynamic loads. And the other part is interior part, which is including partition, finishing, lighting, and others. And of course, outside and as a part of the place that we have a construction is the site. So in this case, including parking, drainage, utilities, and like. But I will skip this part because I think we have discussed this before the mid-semester. So I will focus on the envelope, surface structure, and some part maybe interior. So first, envelope system, I believe all of you have been aware about we have an envelope system in our building, which is somehow kind of skin. And the element could be walls. And the second one is a penetration. Penetration is including door and walls, and then roof. If we'd like to have some illustration, this is the wall, which is separating us from inside and outside, and there is some different type of fenestration, and also the roof. The next question was what kind of mandate of the building envelope. So in this case, we have at least 8 mandate that we consider. So it means if we would like to decide and designing the building envelope, we have to make sure on we have to consider several mandate. First, about mandate to spirit and connect. Why we have to spirit? Because we have to spirit between inside and outside. Somehow we have to also connect between inside and outside. So in this case, maybe like windows and door have different function. For example, like window, we will consider connecting the visibilities, lights, and the air circulation. But window will spirit the movement. And while the movement, besides such a different list of connection, also have a specific connection is the movement. So this is the mandate of the penetration system, the spiration and connection. The other is weathering. We have to make sure that our skin is they should be able to make sure the durability of the building. You can imagine if the building will be let alone without specific treatment, they will decay. The skin will be worsened, and maybe some plantation will be occupy some space. So in this case, we have to make sure that our building should be sufficiently survive in terms of weathering aspect. The second one is structural form, because beside partition, some of the wall may be also functioning as a structural form. And then the other part is the thermal form, because we have to make sure that there is inside and outside with the different consideration of thermal. And also consideration of solar or effect of solar into the form of the building. Besides the solar, we have to consider luminous, the lights, and also aerodynamic form of fluid of air who transfer from one part of the earth to another part of the earth. And maybe our building will somehow diverting them or affected by this flow of aerodynamicity. And then also acoustic form to make sure noises come from outside and not penetrate into the building, or we may expect some level of penetration of the acoustic, but under our control. And then other part is called a hydrological form, because we consider that on site from above there is rainwater. Maybe from below the ground there's also water inside the ground. So this is part of the first element, which is envelope system. The second one about the structural system, which is consists of a bearing system, which actually transforms loads from up down to the ground. And then we have a component to lift the building, like columns. And then we have to have a spanning system, like horizontal support or beam, girders, trusses, and different type of structure. And then bracing to make sure that diagonal bracing or diaphragm able to resist to racking and lateral loads. So the first part may be about the bearing. You may have recognized a lot of possible foundation or bearing system, from continuous footing, isolating footing, some combination, raft, and also star footing. Different type of construction in the footing or the bearing aspect, you can check in your reference. And also have a different type of structure, including this bracing system, lateral load. Maybe for this study or this studio, not all the things could be included, especially should be included, especially for the high-rise building. But this is the list that maybe later on I will discuss more specific about how to choose different type of technology or structure. The other part that I would like to discuss about the mechanical system. Mechanical system has several mandates. First is temperature control. The second, humidity control. And then air motion to make sure the occupant have a forced air circulation. And then also there are some air filtration, and then exhausted system to make sure that polluted air could be managed. And then air change for ventilation or different type of cooling system. And then air balance to make sure that the positive indoor pressure could be avoid infiltration, for example, and then smoke exhaust. So there is a lot of mandate that I have to consider, and how to make sure that the system could be mandate, could deliver this mandate. We have to check about the element. The first element is thermal plant, and then distribution of thermal energy to individual zone of the building, and then how make sure to be able to deliver or have a system to deliver the comfort to the occupant. And then there is control mechanism and thermal energy storage. So this is just not the hostess list of the example, because some of the example actually for the very big building. And I believe your studio will not very big because your design will still considered a simple type of building. So, but just illustration that we have a different type of system, and then we have to make sure that we're able to distribute the air conditioned system within the building, and we have different type of way to deliver the air conditioned system. The graph in the bottom maybe for a small building. Later I will show you a different example of small building. Maybe this is specific not for Indonesia, but for Turkey somehow still relevant. And if we have to deal with delivering or distributing some part of the system into other room or occupational space, then we may use our plafond to deliver. Therefore, you may find that when you need such kind of system, you have to make sure that below the structure, like the girder and the beam, we have to install a ducting system to deliver the air. And maybe other systems should be included, including lighting, sprinkler system, and other. So this is the detail of the previous picture. And for the small building, maybe this is more appropriate or more commonly found in Indonesia. This is like a package terminal unit and through the wall units, so like a split system. maybe very extensively used in small building. So possibly your design, if I don't know whether there is some kind of direction from the coordinator or from the coordinator of this subject, whether we have to include the air conditioning system in the building or not. But this is the simplest one. And then beside the controlling the condition of air, we have to also make sure that our building have sufficient water. Without water, we cannot live properly. So there are different type of system, but you may find the term like indirect water system and direct water system. Other system could be upfit and downfit. The left side, sometimes they call it the upfit, downfit system, because the way to feeding all the devices or all the equipment, all the fixture is by feeding downfit. They for feeding it the water have to go down. But in the direct water system, actually, from the source, we just push up to the different type of fixtures. This is more detailed information about the left side. So you can bring up the waters from the source, maybe from outside, and then we push up with the pump, and then we have storage in the top of our building. And then we can distribute to our fixtures and including the hot water system. So this is more detailed information. And if we combine this with all the necessary infrastructure in the building, it may complicate it because we have to include a cold water system, hot water system, natural gas. In Indonesia, it's not very common, but maybe in Turkey and some part of Indonesia, there are some network of natural gas. And then fan system. Without fan system, even though only second floor, you may have found that the drain system, the stack, the toilet will not properly function it. And if you like to see more simpler, you can see the right side. So the water come from downside, then going up. And then you may find that the red is showing the hot water and the blue is cold water, and then the gray waters come into this flow. And then if you would like to put inside the building, maybe it's depend on the type of construction. But in this case, the example is if you have a wood system, you may find that you have to provide a sufficient space between the wall to make sure that the system can be maintained properly. This is another example. Again, just another example. I think you can have it. You can search in internet a different way to presenting the system. Let's get back into your assignment before the midterm. Actually, one of the consideration to make arrangement of the toilet, because we found that during your process before the studio, there are several considerations that somehow has been overlooked. For example, the configuration of toilet. You know that if you'd like to make an efficient system, where you have to make sure that like the toilet from female and male should be as close as possible. Why? Because then we only able to provide one pipe. And we found that in your design, you miss such kind of consideration. Therefore, you need two pipe because some set of toilet in the bottom side and the other in upside or vice versa. So in this case, you have seen that actually the typology of toilet configuration is we have one pipe and then this one pipe distributed into two sides, similar with the left side and the right side. And then the other one is about the electricity. Maybe in Turkey you have different voltage, but in general you have to go from utility networks from the cities going into transformer, and sometimes we don't need transformer. It depends on the size of the building, because some of the building we can just use a transformer that are available in the system, so we can go into directly into our system. So first we have to go into the meter system because we would like to know how much we consume the energy, and then we go into the panel to distribute, and then we go into different devices. So this is simplified pictures showing that from the source we go into the meters, and then we go into main distribution port, and then go into the lamp and a different type of things. And then the last part is interior system. I will not discuss so extensively because maybe it's not really discussed during this assignment. But if you would like to know about that, you can go into consideration of lighting system, and then acoustic system.
Arif, are you still there? So sorry. Mohon maaf Bapak Ibu sekalian dan juga para mahasiswa, tampaknya Pak Arif keluar dari meeting ya karena koneksi.
Hujan deras sekali soalnya.
Iya Pak, sama. Izin sebentar untuk mengkoneksikan G dengan beliau. Mohon maaf Bapak Ibu sekalian, kita sambil menunggu, mungkin para mahasiswa sekalian bisa mengumpulkan list of curiosity atau daftar pertanyaan terlebih dahulu untuk nanti bisa ditanyakan kepada pemateri gitu.
Halo.
Assalamualaikum Pak Arif.
Waalaikumsalam. Sorry ya.
Yeah, it's okay.
So, when were we?
In interior system, if I'm not mistaken, please.
Okay. Actually, yeah.
Yep.
Can you see this one?
Yeah, clear Pak.
Okay, so yeah, actually the interior system, I said I will not go into details because according to the DTOR, actually it should not be discussed quite details. But of course you can learn by yourself. The next one I would like to discuss about the how. There are two things that I would like to how. First about how to make sure that we able to design our building in a way that the building will comply with all the requirements of this system integration. The second one, because we are not engineers, that's the problem. We are not really engineer, we are an architect. Because we have a problem to, let's say, defining the size of the column, the size of the structure. So in this case, we have to find a guideline to make sure that if we are designing our building, as we are not engineers, yes, somehow people say that architect is engineer, but we are not true engineers, because we have our friend in civil engineering that they are able to, in details and carefully calculate all the engineering structural engineering requirement. So the question, how we can deal with such kind of situation that we are not engineers, but we have to able to provide a design that engineer will not complain with our design. So in this case, we have a nice book. The nice book is about the Architect Studio Companion, the Architect's Studio Companion. Actually, this kind of rule of the thumbs for preliminary design. What the specialty of this book, the book from Allen and Yano, is even though you are not engineers, you are an architect, but the size of the structure, the size of the space, the size of the element of the structure, even though you are not engineer, you are able to estimate in a way that the engineer will not complain. Complaint in terms of engineer is maybe they said, wow, your column is the way is too big, or the span is too wide, or the way you're designing the column is too small. You know, if you're designing something is too small or too big, which is part of the structure, it becomes complicating the process, because we expect that after you deciding the size of the structure, the size of the column, the size of the bearing system, the size of the spanning system, we expect that actually when we deliver this preliminary design to our engineers, our engineers, which is civil engineering, they will start to calculate properly, and later on they said, okay, no problem, I can deliver the detailed drawing and calculation of the structure. So again, this book is very nice book. Why? Because there is a kind of rule of the thumbs for different type of element in the structure. For example, designing structure and including designing space for mechanical and electrical service. Let me show you several clues. First, there are some special consideration to the system indicated that you wish to, let's say, if we'd like to make irregular building forms, what kind of consideration? Because somehow people will ask you to have kind of regular, but in some other matters, some other situation, they will expect you to have irregular building forms. And of course, you are able to make something very regular, but or very irregular, but everything should be correct, should be properly designed. So this is a list. This is a list of the concern of your design, including first about irregularity, and then how the exposure of structure while retaining a high resistance rating, and then different lists of consideration. So in the books, you will find that if you consider wood and masonry, you will find the answer in this page. If you consider the steel is you will choose the steel, then the answer is here. And if you consider that the concrete is the solution, then you will find the list is here, including the precast concrete. So again, this nice book is kind of guideline. If there is some tick, that means it is appropriate. If there is no tick, it means it's not appropriate. So again, this will help you to make sure that whatever the system or system component that you are going to choose is correct or properly selected. Then the other part of the nice thing about this book is about the understanding of a different structural system and the capacity, load capacity, and the different capacity of spanning. For example, you have a wood, where you brick, you have steel, you have set concrete, precast concrete, and pneumatic. So you can see this bar. You can check that actually wood, they have let's say maximum 6 meters for the choice. For the decking, maybe farther. And you can see that there is minimum and the maximum. Minimum maximum is just showing that this economist way. It doesn't specifically say that we cannot do in a longer way, a longer span, no. But this economic system. Of course, when you say that I would like to have a longer span, the implication is the cost. Because our friend from civil engineering will complain, no, you cannot do this with the wood. You have to add something, this and that. It's even cost. So in this case, actually, the limit of minimum and maximum is not really capability of the wood, but capability of a system to make sure that it's quite effective and efficient. So again, this is a nice book, according to my experience, because we are not engineer, but we are able to make a design that actually the engineer will not complain. So you can see the concrete and there are different type of system. And then of selecting the system of construction, the book also inform us about the possible loads in the room, in the space that we occupy. So in this case, there is a list of category of loads, from the light load, medium loads, and then heavy loads and very heavy loads. And a different type of occupancy will indicate how much the load for the floor that you occupy. For example, assembly area actually include in the medium loads. But building corridors actually considered as a light load, maximum to a medium loads. But garage, because you have to bring your car, the passenger cars could be in the category of light loads, but truck and buses could be in very heavy loads. So again, this book is very nice. We thought really you are become engineers, you will able to understand actually whether your room will be occupied with very high loads or very heavy loads or light loads. Why is this important? Because in the next part of the books, you will find actually how much the size of the structural system, because the graph using a different range of light loads to very heavy loads. So you can use this table to really check whether your building is occupied with certain activities with light load or very heavy loads. Again, the next one, you can consider, okay, if your building is actually very heavy loads, you have to consider what kind of structure. For example, like wood, okay, you love wood very much, like Pak Haji, he loves wood very much. But we have to consider if we have a garage, what kind of possible structure we can use? We cannot use platform frame, but we have to use timber frame, because timber frame is possible to have very heavy loads. Masonry have different characters. Steel also have different characters. Side cast concrete also different character. So again, please check carefully to make sure that the activities that you will occupy will be accommodated when the system will have been occupied is sufficiently provided the proper structural system. And again, the other nice thing about this book, you don't need to use calculation tools like calculators, computer, whatever. No, just using the graph. Why? Because architect love the graph. Architect love the graph. So using this graph, you can easily estimate how much the size of structure without actually you have to calculate something. Just using the graph, and then you will find what kind of system and how much, like the thickness, for example. So in this case, for example, if you would like to create a wood decking, you would like to have a deck using a wood. First, we have to consider about the span. Span maybe 1.5 meters, 3 meters, 4.0 or 6 meters. And then you can see here, there is a light color and there is dark colors. Dark colors showing that if you have very heavy load, so you have to consider somewhere number between this span. So again, you can see that this like 3 meters, this is the nominal depth that you have need. So the thickness of the wood. So this is nice thing because then you don't need to have calculator in your hand, but you can just watch checking the graph and you're able to decide the size of the structural element. The other example, you may have to decide using wood truss, whether you're using triangulars, pro string, or parallel cords, and you can see that the size of the, let's say, the depth or the height of the structure, you can directly find in this graph. Again, the dark color showing if you have a heavy loads, but the light one you can use this light colors. So again, this is very easy to use. This is another example, and you're also able to find a different type of structure. This as example, I'm selecting the wood as an example. Okay, the next one I would like to discuss about the economic consideration. This is, for example, about the concrete, about the concrete column design. Well, you may have a different irregular system of your structure, but in general, we'll think about whether it is appropriate or not. It doesn't mean that if you choose a concrete, then you have to be very regular. No, but there is always question about whether it's economical or not. Because column size, maybe if you'd like to be economical, you have to check as little as possible. And then, if possible, column location should be continuous. And then column placement should be uniform as ordered. And then irregular or square columns should be conform to standard orthogonal limestone. Otherwise, it will complicate form works. Again, it's just talking about economical concrete column design, not about whether concrete can be designed with such kind of irregularity or not. So again, this is just note that you may have irregular system, but please consider regular first before going into irregular system. Why? Later I will discuss about it. So this is kind of consideration if we'd like to have irregularity. So there is kind of consideration. For example, the best one is the square. But in the case that you have irregulars, for example, going into rectangulars, there is kind of rule of the thumb. Please don't extend this irregularity with two type of lengths. It doesn't mean that it cannot be done, but it's just more economical. Or if you would like to deviate the location of the column, there is a consideration of not more than 1/10 length of the maximum. So again, this kind of irregularity that you can do, but the best one is the irregular one. But if you do irregularity, please consider such kind of consideration. Why? Because it's just a matter of economical consideration. Okay, if you have only one building, that's not really affecting. But if you have a very big building, or you replicate the design to be built as 1,000 of building, every additional cost will multiply by 1,000. So it becomes very, very expensive. Okay, so this again a consideration if you would like to have irregular system. The next one is about another example for the concrete. So if you would like to know about how much the size of the column, because column always kind of consideration, how much should I use? So this one is an example of if you'd like to have a question about about the tributary area, the area that will be pierced by this column. You may have a different distance of the column, therefore the area will be different. And if the area is different, then the size of the column will be different. Don't worry about this. The dark dots. This is about the iron that you have to put inside. Let the civil engineer will calculate properly, because as long as you have a proper sizing, they will find. They can add the number of the irons, or they can add the quality of the concrete. So it doesn't matter. But if you are not following this graph, you may go into too big or too small, which is very problematic when you start to designing in the real projects. Okay, let me go into the different part of the building, which is roof. Roof, like kuda-kuda. In our material art, we call it also kuda-kuda. The illustration actually showing that our roofing system, we have to make sure that it's like our foot, which is have to be very strong, and should be a pair, left and right foot, for example. Why? Because in the first assignment during the before midterm, many students actually they are not considering that the system should be at least have 2 points. 2 points as a part that your system, your spanning system, have to locate it. So in this case, please always consider 2 points. 2 points within your system, within your grid system or whatever. Never use only one in the one side and there is no foot in another side, because become very, very vulnerable from the earthquake. In extension of such kind of spanning system, we also have bearing system with a beam system. And again, we also have an analogy of foot, but you have to consider 4 foots instead of 2. Why? Because become more stable. Like you have cow, you have different type of animal, including this animal. What we call it? What's the name of this? Yeah, yeah. Whatever the animal, you have to have like a pair of left hand and right hand, left foot and right foot. So again, please consider such kind of consideration. I have an example that when people try to make a deviation of such a regulation, such order, this is an example that one of the engineers or the architect would like to have 2 grid system, the grid global system or the additional system. So in this case, maybe we have a different way of measuring the distance of the column. And in this case, actually, we try to move the grid in a way that we don't need to have, we don't want to install such kind of column. So when we go into structural calculation, maybe the most economic one, we have to keep this grid with the column of the red column should be here. But again, it doesn't mean that the building cannot be constructed. Just we need to more economical system. So maybe the most recommended one is the simplest one, like we have in the bottom. It is very simple. The square, the order, and then everything very simple. It is very simplify the problem that you will face. This is another way of simple way to make the order. There is some kind of variation, but it's considered as still simple. And this very simple one, this is the design by Miss Van der Rohe. Miss Van der Rohe is actually have a very nice statement. Less is more. So less complicated is more. So this is the example of the design by Miss Van der Rohe that actually is very simple, but the design is still nice. This is during the construction, and this is more or less about the design of the system that actually very simple, very strong, very stable, and it's very nice. Of course, people start complaining why we should have kind of very rigid and not nice building because the form is very simple. it is possible to have kind of more complicated shape, because I don't want to have more dynamic system. Yes, of course you can do that. The next question is actually, if we consider these two system to building, to design, A and B, I would like to hear from you. How many of you actually consider this is more simpler, A or B? So for someone who consider that the A is more simpler, please raise hand. Let me check how to check how many people. Oh, we have 200 participants. I cannot count actually. Can people start raising hand? How many of you consider that the A is simpler than B?
Students, there's still one.
Okay.
Still counting. Please, student, how many of you would like to think that A is simpler?
Yeah.
Only one, Arif. Only one student.
Okay, now I change the question. How many of you actually consider that B is the simpler one?
Two and still counting. Please, students. 4, 5, 6, still counting. 12 right now. 16, 17, 19, 25.
Oh, you can count from the barrier. Okay, I don't know. Okay.
Yeah.
Okay.
There are 25 at most.
Okay. Okay, at least we know that more people prefer to have B as the simpler one. Yeah. Okay, this is my assumption. So okay, let's check. Let's check and compare the system. Even though the design look like more simpler than A, but yes, you're right. Most of you are right that the B is more simpler. Why? Because in terms of structural system, it's more simpler. They have a square grid, and everything in the line of the grid, and some kind of variation actually only the wall. So again, don't worry about simple structure, because the shape of the building will not necessarily simpler. You may have very dynamic design, very dynamics, and you can see that actually I would like to make some. I don't know whether I can have notation or not.
Yes, you can.
Oh no, I don't I have to change using my pen. No, I cannot. Oh yeah, sorry. Yeah. So you know, even though it looks simpler, the grid is not very simple, because some of the grid is actually outside of the grid. It's very many of the part is actually not considering as a nice regular grid of structure. Even though the building is very simple, just a square, it's very simple, but the structure is not simple. On the other side, this building, even though it look like very complicated, but it's more simpler. Why? Because all the structure is using very nice grid. Only the outside of the building could be some kind of deviation, but actually the structure is very simple. It's just a way to put the enclosure or building envelope a little bit deviated from the structure, but the structure itself very simple. So I think most of you has been in very good understanding about the simple structure and regular system, which is not necessarily will affect your design in a way that is too simple, because you may still able to have very nice and dynamic building with a very simple structure. So okay, let me continue to other parts. I think I have seen someone raising the hand, but maybe Not now. Okay, later. Okay, let me continue. Yeah, again, if you would like to check, you can see that some part of the building, even though it looks like simple, it's not really simple. Considering this one is actually more simpler, even though the building envelope is a little bit more complicated, but structurally speaking, that is more simpler. And then other consideration is stair, because you have to consider egress later beside the structure. You have to make sure that you have a very good system to have an emergency system. So please consider also the location and the consideration of that end, whether it is okay or not okay, and different consideration. And then there is some list of the stairway and ramp proportion, which you can find in the books, and which one you can do and which one you cannot do according to different building national code. The last part of this lecture is discussing how to present the integration aspect of your idea, because we would like to have in your reports something nice to see, nice to learn, nice to know, nice to observe. So in this case, the list of example of how to present the integration aspect of your idea. So this is the first part. So maybe this more macro level of overview. You can say that first we have to provide anatomical section, showing that some part using different type of system. Okay, this is using tabular system, this is using cable tension, this is using reflective system. We use concrete piling, and then we have physical plan located offsite and other things. So again, it's showing how the integration has been done in your design. So just another example. This is the design of the airport. You can explain the nice thing about your idea using this anatomical section. So this list of example, feel free to learn later from the books. Again, this is your chance using this section or anatomical section to show the idea of the integration. Put some additional information, detail, description, and others. Therefore, people or your client will understand what are the special things about your building. Again, this is another example. You can discuss about the structure, the finishing element, the ducting system, the flooring system. Many other systems can be presented nicely, including what kind of spanning system, what kind of bearing system, what kind of flooring system. So this is a list of examples that you can do later on when you would like to present, maybe at the end of your projects. You can have a very detailed information on that, or it is also nice if you're able to make a three-dimensional information like astrometry with the list of the explanation with the size, about the feature, about many things. Again, this is another example of nice example that if you're able to provide in detail, it becomes very nice information that your building is very integrated. So you can have like a section including the perspective picture of the design. This is another example. This also the scale is similar with your design, like a building scale, housing scale. This is a little bit bigger green building, but again, showing just show all ideas, whether it's a mechanical, building envelope, pumping system, or whatever that. Okay, and then the last part, you have to provide summary report of your integrated design. Maybe you can do it in the beginning of the design or today. Sorry, this is too small, but later I think it will be circulated. So in this case, actually, you're able to show the summary of your ideas. For example, like the description of the projects, and then you're able to decide who is the teams or the architect, and then general information about the projects, and then description about the site, and then explaining about the structural system. Let's say what kind of foundation system, what kind of vertical members they can use, what kind of horizontal span that you can use. And then you're able to also describe the envelope system. glassing maybe, skylight maybe, cleaning system, or roof system. And then you're able to put the HVAC system in your explanation and other information. So you can do it in the beginning of the projects, and later you can able to check at the end of your project whether it's still consistent or you have some additional idea, more detail, more nice information about it. So I think that's all from my side. Thank you so much for your kind of attention in the kind of question, and will be welcome. So we can discuss, and maybe additional information from other lecturer will also welcome. So thank you so much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Pak Arif. It's very fruitful material from Pak Arif. So students, I would like to invite you all to ask to Pak Arif or maybe respond to what Pak Arif has already shared to you. I think it's very interesting that we have lots of system in our building design that we have to think about. And then to our distinguished lecturer, please, is there any addition or maybe respond to Pak Arif's course material, please? Silakan bagi para mahasiswa dan juga para Bapak Ibu dosen yang akan merespon.
From the lectures will be additional statement, not question.
Respond.
Just respond or comment or additional information that maybe I missed somehow.
Please, maybe Pak Ilya or who has to think. Is there anything?
Yeah,
please, Pak Ilya. Thank you.
I'm sorry that I'm not able to use the virtual background, but I'm really appreciate Pak Arif presentation, giving the idea of this integration, and also to give an example that don't be fooled by the envelope. That structure can be very simple, but the envelope can be very complex, and it can be still an integrated architectural work. So I think if we come back to the Design Studio 3, that addressing more on the way of doing with the modules, and we should consider also the first level of modules, namely the system of the material, and number 2 is the system of the function, the unit, and the last is the module in terms of the integration of the structure, system, infrastructure, and also how this enveloping material can be fixed into the right place. So I think it's very interesting, and also at the same time a challenge for the student for this coming project, for the second project, especially for the UII student, to make sure that the line of argument, the line of design in the Studio 3 from materials into the modules, and then push forward maybe in the future if the situation makes possible, somehow exercising using 3D printing or maybe laser cutter in order to make sure that the idea, although however complex, can be integrated and produced in simple way, because simplicity answers complexity in terms of the production of or construction of architecture. I think something like that. Thank you, Pak Arif.
Thank you so much, Elia, for the notes.
Yeah, thank you, Pak Elia, for the notes. Thank you, Pak Arif, too. Is there any addition, Bapak Ibu? Apakah ada tambahan? I'd like to invite our distinguished lecturers, Aisyah, Bu Hastuti, Pak Fajri, please, is there any addition for our students? Bu Hastuti, maybe? Please, Bu Hastuti.
For me, no. I think for me it's enough.
Okay, thank
Very
you, Bu
clear, I
Hastuti.
think.
Thank you, Bu.
Thank you, Bu.
Okay, I'd like to invite once more to our students to give response or maybe asking something to Pak Arif about introduction to building systems. I know it's very fruitful discussion we have right now. Please. And there's a door prize for the best responder. I've already stated. Please, students. Take your chance. Okay, there's no one asking.
Oh, there is chat. What kind of chat? No. Oh, chatting, informing about.
Yeah.
Price.
Yeah, please, student, is there any question or any hesitation to design something that maybe your mind is too difficult or is too complex or something like that? We may discuss right now.
Yeah, actually, in the chat room, you will find the material, the presentation material, because some of the picture are a bit too small, the text is too small, so you can read and have a look if there is kind of question could be come from this material.
Okay, so Pak Arif, if there's no question right now, would you like? Oh yeah, there's a question. There's someone raising hand. Mas Hafiz, if you'd like to open mic and share it. Mas Hafiz just raised hand just now.
I think Hafiz just want to
Yeah, just want to applause. Yeah. Okay, then Bapak Ibu sekalian dan juga para mahasiswa, rasanya mungkin sudah disampaikan semua materi ya.
Sedikit Bu Syarifah.
Oh baik, Bu Astuti, monggo. Please Bu Astuti. Ya.
Halo Bu Syarifah.
Ya Bu, silakan Bu. Please Bu Astuti.
Suaranya tidak stabil ya, kan hujan deras ini.
silakan
Kelihatan kok Bu, terbaca kok Bu, terdengar.
Terbaca ya.
Iya, terdengar Bu. Silakan Bu Astuti. Loud and clear. Ya.
Sedikit bertanya Pak Arif, kalau tadi ilustrasinya kan memang simplicity dengan bentuk-bentuk geometris yang simple dan mungkin rasional ya. Nah, dalam menanggapi yang tugas kedua ini kan multipurpose building sangat mungkin nanti bentuknya itu pasti diharapkan yang dan juga menjadi clue dalam TOR itu inovatif dan futuristik gitu ya, sehingga dibayangkan bentuknya itu pasti pating kruwil begitu. Nah, untuk untuk mendapatkan struktur ataupun infrastruktur yang efisien, itu strateginya seperti apa nih? Matur nuwun Pak Arif.
Terima kasih Bu Astuti. Silakan Pak Arif langsung direspon boleh.
Yes, thank you, Bu Astuti. Actually, Hafiz also asking the same way. I mean, she asked about weekend structure to circular or wave-like building. Well, there are two possible ways actually, because forms could be just an envelope, but the structure itself still very regular. This is one of possible approach. But the other, if you would like to include the complicated, let's say, more complicated structure, please still consider that whatever you will do, think about you always have to have a 2 foot right foot and left foot. Always in the like a centipede, yeah. Not centipede. Is centipede? Yeah, centipede.
Yeah, it's centipede.
A centipede. They always have a left and right, even though they have a very long body. But there is always symmetrical left foot and right foot, left leg and left leg. So you may have a different type of dynamic of the system, but just consider that the pair of the structure, because this is simplest way, and you may have a different sizing, but please still consider the pair. So this is the safest one. So this is, I think, the simplest question. I hope it's quite simple. So don't worry about the dynamic things, but keep it simple. No, sometimes people keep it simple as the another S. I would like to, I don't want to mention the last S. Keep it simple. So yes. Oh, okay. There's another question.
Yeah. There's another question from. So sorry for Mas Hafiz. Is it clear enough from the response from Pak Arif? Maybe if I may request Pak Arif later discuss about the circular or wavy building or something like that for the example like that. And then there's a question from our tutor. It's actually our tutor, Mas Dodo. The structure is the skeleton, the MEP is the nervous system, and facade is the skin. What is the heart of the building? Okay, it's just like a query. Okay, and then there's a question. It's very interesting. Okay, and then the question from Mas Lanang Taufiko. Sir, I have a question from the minimalism concept of Ms. van der Rohe gave. Is there any possibility to combine it with local tradition? Okay, maybe with some simple structure, but also provide place for local sculpture to give ornament, for example, to the design. Okay, that's very interesting. Arif, please respond for it.
Yes, very
Thank you.
very interesting question, but the question from about the skeleton and the nervous system. Okay, let me discuss about the new things, new generation of building, the Internet of Things. I just got 3 bulbs from Barbie. You know Barbie?
Yeah, it's trending right now, right?
Barbie. Barbie. I got actually not myself. My daughter win the competition. Got many Barbie. So the Barbie, actually, I just asking them to hello Google, turn on. It's turn on. Please change the color into blue. It changed into blue. Turn into red. It changed into red. So where is the heart? Maybe the heart is not in our home. The heart is in Singapore or in US, because the Google server is there. So it's quite challenging, actually. The funny thing is, another daughter of mine. Now he can turn on and turn off the lamp of the house of her friend, which is in Jakarta. Why? Because when install, he also install in her phone, in smartphone. So actually, she can turn on and turn off the whole lamp in her building in Jakarta right now. So where is the heart? So we are going into new generation of housing, actually. So if you're asking about heart, maybe this is the answer. Heart, brain, and feeling, and whatever. Because again, you may change the colors of your building according your feeling. You know, if Ibu Lia, if she always doing chatting or actually like tweeting every day, every night, every day. Actually, Twitter able to analyze whether you are happy or not happy, and the happiness of yourself could change the color of your lamp. So where is the heart? In the Twitter home office. Oh, sorry, the center of Twitter. So again, maybe not the exact answer, but maybe this is the new way to answer. It is not in this books, but this is a new way of answer.
Assalamualaikum.
Waalaikumsalam.
Pak Arif, I'm
Yes.
questioning to represent students.
Oh yes, please. Who is
Professorship students, is it Pak Suparwoko, please?
actually asking for student, not asking, but the lecture not for asking, but for additional student. So please, Pak.
Yeah,
Please,
I
Pak.
think your presentation is very useful and very nice, Pak Arif.
Thank you, Pak.
But the question is, how do you think first? The skeleton, the plan, or the simple structure? Or you will double counting to think,
Okay.
or blended thinking? How do you think about that?
Well, if you are following design thinking, because we have to think with the design thinking. The first step is actually empathizing. Give an empathy to our client. What are their needs? What are their needs? It's very important. Then going into ideation. Ideation is generating ideas. When the generating idea, you may come from the structure first or the activities or whatever. But first, you have to make sure that the idea, your idea, have to be relevant to the problem of the client. And then after that, you go into next step, which is actually prototyping, providing drawing and whatever, and doing a testing. So this kind of list, which is actually iterative, Pak Woko. It's not linear; it's iterative. You can start, but please start from the sense that you understand their problems. We have to understand their pain. What are their pain? Because we are coming to relieve their pain, not adding with their pain. Please, architect, don't make additional pain for them. Please come to them to release their pain. So maybe this is not, again, not answering the question, but this is the way I answer, Pak Woko. Sorry, Pak, you are
Still mute, Pak Suparwoko.
Thank you,
Yeah.
Pak Arif. In my thinking, I think we should do first how to respond the client, and then try to create the plan or skeleton, I think. And
Yes.
we will test the structure after that. Although it will be reiterate process, I'm agree about that.
Yes.
Yeah.
Yes.
Okay, thank you,
Of course,
Pak Arif.
we have to follow the function. Form just following the function.
Yeah.
Yes. It's true.
So do first
Thank
the
you.
form and then test the structure, I think. Thank you.
Yes, structure is part of the way to accommodate the need.
Yes, thank you, Pak Arif.
Thank you, Pak Woko. And the last question, Pak Arif, about minimalism and maybe ornamentation.
Okay, let me try to answer with the different type of chloride concept about the methodology or framework of designing. You may have following the pattern base. You may following a force base, which is the other part is actually concept base. The question about putting ornaments or traditional ornament, I think you have to consider in which part are you going to design, using the framework of a pattern base or concept base or force base. Because when you're thinking about minimalist approach with the traditional approach, you come into force base because you put something in the conflict. One to be minimalist, the other will be very traditional, a lot of details. So it's mean you go into this part, and the other part, if you would like to have a different pattern base, you have to keep the pattern according to the situation. And the concept base, if you want to be really traditional, then please keep it traditional. If you want to be minimalist, please keep it minimalist. But if you force yourself to be in the conflict zone, you have to go into force-based analysis or force-based framework. And in the Pro-Write books, specific mention about TRIS methodology, which is my specialist. Sorry for that. No, but TRIS methodology is something that's specifically mentioned by Pro-Write in this book, discussing about something we can use the pattern base, and also you can use these tools as part of the force base because they're able to resolve the conflict. So I think this is the answer. I hope that answering.
Yeah, it's quite answering, quite helpful. Thank you, Pak Arif. It's quite fruitful discussion we have here. And students, we will add reading list from the course material to your Google Classroom from our lecturers. Thank you, Pak Arif, for responding. Is there any more questions, student? If you'd like to, or it doesn't have to be question. Yeah, you may share your idea responding about what Pak Arif has said before, please. If any. We've already take note of two students and one tutor asking. Is there any more students? If there's no more questions, so yeah, we have a fruitful discussion. Thank you, Pak Arif. Thanks to your course material. It's very, it's very comprehensive, I guess, about the systems, all the systems that that related to the architectural design, if I'm not mistaken. So, students, please take notes about that, about what kind of system, what kind of adaptations you should have from thinking about the systems and your sites and etc. And thinking about the modularity that Pak Ilya has already stated before, and all the things that already designed in the first half of the semester. So I'd like to thank you, Pak Arif, for the fruitful discussion and the meaningful presentation today. Let's give a virtual applause to Pak Arif. Thank you, Pak Arif. Yeah, and students and all lecturers, you may check for these recordings in our YouTube channels of Department of Architecture Universitas Islam Indonesia, and all the course material will be sent to your Google Classroom by your lecturers. So please take notes about the materials. And after this, I would like to invite all the lecturers to open the Zoom of the parallel class, so you students can join to the exact class, as stated before. Okay, thank you for your attention and for your cooperation, all students and all our distinguished lecturers, and of course to Pak Arif. Hope it all will help all your preparation for the next half of the semester. Let's say Alhamdulillah all together. Alhamdulillahirabbil alamin. Hopefully all is help for you. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thank you so much, everybody.
Thank you, Pak Arif.
Thank you. See you. Bye-bye.
Thank you, Pak Wing.
Thank you.
Thank you, Pak Ilya.